Okay, this lesson we're going to be simplifying radicals. Remember, a radical is like a square root, a cube root, fourth root, and so on. So some properties of radicals is the product property. That tells us if we have a radical and there's a couple of things that's being multiplied inside, we can split it into two if we would like. So if we look at this first example here, I could split this into the cube root of 27 times the cube root of x times the cube root of y squared. So it means the same exact thing. Okay? All right, so quotient property. If you're dividing under one radical, you can split it into taking the, in this example, fourth root of 16 on top over the fourth root of t cubed. Okay? All right, so remember this little bitty number is called your index. That's how many groups you're going to want to have. So we're going to be simplifying radical expressions. So first example, we're going to simplify using exponent properties. So notice this says 3. We're taking the cube root, which means we need 3 of the same number, because when you take the cube root, you're trying to find what number times itself 3 times. That gives you that. Okay, so I'm going to start out. It doesn't really matter how you work out your factor tree. Okay, so 2 won't go into 625. I know 5 will. 5 times 125, and then I'm going to keep going. 5 is prime, so I can't keep going. I keep going on the 125. 5 times 25. I can keep going, so that's 5 times 5. Okay, so you keep going until you have all prime numbers. And I like to mark these out, so that way I'm only looking at my prime numbers. So I want to group 3 of the same number together, and I'm going to circle them. Notice I have 1 5 left, and I'm going to box it in. Whatever is boxed is going to stay under the cube root. So I'm going to bring out the 5 times 5 times 5. I'm going to bring it out once, so bring out the 5. So whatever you have a group of comes on the outside once. And then I write my radical. Don't forget the index 3, because it's the cube root, and then whatever is boxed stays under your radical. So those should be equal. If you were to type in cube root of 625 in the calculator and type in 5 cube root of 5, they should be the same decimal. So when you're simplifying, it's just like simplifying a fraction. You're reducing it. So you're taking out all of your perfect cubes or squares or whatever your index is. Okay, so this is my answer. So looking at part B, so I have 540. Notice my index is 2. So I'm going to be looking for 2 of the same number. So again, it doesn't really matter how you start it. I just like to start with your smallest if possible. So 2 will go into 540. So that's 270. Keep going. 2 times 135. So 5 will go into that. 27, and then 3 times 9, and then 3 times 3. So there's lots of ways of doing this. It doesn't really matter as long as you're doing your multiples of your whatever number you're looking at. So again, once you get all prime numbers, you can mark through them. You don't have to. I just like to. So since my index is a 2, because this is the square root, I want to find 2 of the same number. So I'm going to group them together with I'm going to circle them together. And then I'm going to box in whatever is left. Sometimes you have more than one number. Box it in. So remember, whatever the groups are, I'm going to bring those on the outside. So I'm going to bring a 2, and I always multiply if there's a couple of them. So I have 2 times 3, because both of those come on the outside. And then whatever is in the box stays on the inside. This is square root, so I need a 5 times a 3. Again, you always multiply whether you bring them on the outside or inside. So that's going to be 6 square root of 15. Again, you could type in square root of 540 in the calculator. Type in 6 square root of 15. It should be the same decimal. So you're just simplifying your radical. Okay, so notice this one that we are adding. When you are adding, your index and radicand must be the same in order to add the coefficient. So I first need to simplify each piece. So again, it doesn't matter where you start. I just like to start with the smallest. So 2 will go into 80, 40, 2 and 20, 2 and 10, 2 and 5. Those are all prime, so I need to stop there. Now look at your index. You're going to group 4 of them together. And then I'm boxing in the 5. So I'm going to bring out the 2 once because I only have one group. Don't forget your little index 4. And then I have a 5. Notice on the second one, I'm not able to do anything with 5 because that is a prime number. So I'm going to just bring down the plus sign, the 7, 4th root of 5. So again, in order to add, your index and your radican, which is the term under the radical, have to be the same. It's like a variable. They have to match. So these match. All I have to do is add the coefficients. So 2 plus 7 would be 9. And then I leave my index the same and also my radican. So 9, 4th root of 5. So if they don't look the same at the beginning, you have to simplify to see if they end up being the same term. Okay, so index and radican must be the same to add or subtract. All right, let's look back. So we're simplifying radical expressions containing variables. There's 2 different ways of doing this. You can use index method or rational exponent method. I like looking at the index. Okay, your choice though. All right, so I'm going to simplify it. Remember, this is the same thing as square root of 28 times the square root of f to the 10th times the square root of g squared. So I'm first going to look at my number here. So I'm going to simplify like we were doing in the front. So 2 and 14, 2 and 7, and that's as far as we can go because those are prime. So it's a square root, so I'm going to group 2 of them. So that would be 2 square root of 7. And then f to the 10th. So that really means 10f. So I'm going to write it out here, and then I'm going to show you an easier way of doing it. 1, 2, 3. Okay, so you group it the same way. So how many f's do you have grouped? 1, 2, 3, 4, 5. So that would be f to the 5th. There's nothing left over, so it's just perfect. It would be f to the 5th. So we have g squared, which is g times g. I grouped 2 of them. I just have a g. Okay, so our answer, there's nothing left on the s and g's, so I should have a 2f to the 5th g, and then the only thing I had left over that was boxed was the square root of 7. I'm going to show you an easier way of doing it all at once. Notice the index is 2 here, and this is a 10. I can divide it. It divides evenly. 2 will go into 10 5 times. 2 will go into 2 1 time, so I have that g on the outside. So that's an easier way of doing it. But if it helps, you can write it all out like the numbers. Okay, so this next one, I'm just going to leave it all together, but you're welcome to write it out like we did on part A. So first I have to check my 125. So 5 times 25, 5 times 5. And then I'm grouping 3 of them. Notice they're all there because that is a perfect cube. Cube root of 125 is 5. Since it has a negative sign, I'm going to bring that on the outside. So that's perfect. It's a negative 5. Now, notice here that I have 3 as my index. This is a 2. 3 will not go into 2, which means I'm going to go ahead and set up my cube root. I'm still going to have a squared underneath because there's not 3 that I can bring out. Looking at your b's, 3 will go into 10 3 times, so that would be b cubed, and then I would have 1 left over, so there would be 1 left. Again, if it helps you to write out 10 b's, we're grouping 3 of them. That's my index. So there's 3 of them, which would make b cubed, and then you have 1 left. So that's exactly what I got. Then next one, 3 will go into 9 3 times, so that's c cubed, and then there's not any left over. So this would be my final answer. So again, if it helps you to write it all out, write it all out. Okay, so part C, 3 times 9, 3 times 3. My index is 3. Notice it's perfect because 3 times 3 times 3 is 27. So I have a perfect cube there. And then looking at your variables, 3 will go into 12 4 times with nothing left over, so it's perfect. So if we were to write it all out, there would be 4 groups. And then 3 will go into 3 once, nothing left over. 3 will go into 15 5 times, and nothing left over. So this is perfect, which means if I were to multiply 3x to the 4th, yz to the 5th times itself 3 times, it should give me back this radicand underneath because it was perfect. So if you end up not having anything left over, you should not have a radical in your answer. All right, let's look at another one. Notice 3 is prime, which means that's going to stay under the 4th root. We can't take 4 of them out. 4 will go into 12 3 times, so 4, I'll leave some more room. So 4 to the 3rd power with nothing left over. 4 will go into 11 twice with 3 left over. 4 will go into 25 times with nothing left over, so there's not a t left. So again, if it confuses you, the way that I'm doing it by dividing it, write them all out. There's 12 r's. You're grouping 4 of them together. It's perfect. There's 3 of them. Keep going. You can do your s's, you can do your t's. So if that works for you, then write it all out. Okay? All right, let's move on. So the next page, we are having to rationalize the denominator. So a radical expression is in its simple radical form. Make sure that all of the radicals are in the numerator and not in the denominator. A radicand is not a fraction. So to achieve the last 2 criteria, rationalize your denominator. So to rationalize the denominator, you're multiplying the numerator and denominator by a specific chosen form of 1. So whatever you multiply the denominator by, you have to do the same to the numerator. So it says let f, g, h, and j be rational numbers. The expression f square root of g plus h square root of j and f square root of g minus h square root of j are called the conjugates, which is like the opposite. So notice the same, it's exactly the same except one is plus and one is minus. So if you remember difference of squares when we did that, if we were to multiply it back through, the middle terms would cancel out. Okay, so if we are given a single term, so all one term like we have here, we can split it up. Remember, we can split it up. Make sure you're always simplifying it first, numerator, denominator. And then notice we still have a radical in the denominator. So I need to multiply it. Since I have the cube root of 5, I would need to multiply it by cube root of 5 2 times because I would need to multiply it by itself 3 times to get rid of the radical. So whatever I do in the denominator, I have to do in the numerator. So that's exactly what happens there. If you have the sum or difference, involving square roots in the denominator, you're going to use the conjugate in order to get rid of the radical. So for an example, here we have this example. We need to multiply it by its conjugate, so the same exact thing but the opposite sign. If you use FOIL here, because this is a binomial times a binomial, the middle 2 terms are going to cancel every time, and then you will not have a radical in the denominator anymore. Okay, so let's look at an example. So first thing I need to do is I need to look, since I'm dividing, I can first look at my coefficients and see if I can divide them, because those are numbers. So if I do 288 divided by 72, that gives me a 4. So we want to simplify. And then notice my a's, when we divide, remember laws of exponents, we subtract the exponents. So that would be a to the 8th. And then same thing here, we have b's. Now this is a 1. So if I have 1 minus 2, that gives me a negative 1. So if it's negative, we would need to put it to the bottom. So that would be a b on the bottom, because that means b on top, 2 b's on bottom. We have 1 left on bottom. Okay, so once we simplify the inside piece, remember we can break it into 2. I'm taking the square root of the numerator, and I'm taking the square root of the denominator. So simplify if possible. Square root of 4 is 2. It's perfect. Remember, that's 2. And then 2 will go into 8 4 times, so that would be a to the 4th. So that's perfect. We didn't have anything left over. The square root of b we can't do anything with, because we wouldn't have 2 b's. So this is the part where we have to rationalize it. If we have a radical in the denominator, in order to get rid of a square root, I multiply it by itself. But I have to do the same exact thing to the numerator, because this really equals 1. If I multiply something times 1, it gives me the same exact thing. So I have to multiply. When you're multiplying with radicals, the only time you can multiply the radicands is if the indexes are the same. So I have 2a to the 4th, and then I just have the square root of b. So I only can multiply inside pieces, outside pieces. These, square root of b times square root of b, is the square root of b squared, which is just b. So anytime I multiply a radical times itself, or square root times itself, it gets rid of the square root for me. Since I no longer have a radical in the denominator, this would be my final answer. Okay, let's look at part B. So first look and see if you can divide it. I can't divide it, so I'm going to separate it. Cube root of 1, it is perfect. It's 1. 1 times 1 times 1 is 1. And I can't do anything with the cube root of 7x, so I'm going to leave it as is. Now, we can't have a radical in the denominator, so I have to rationalize it. Now, this one's not a square root. This one's a cube root. So whenever I do this, I'm going to have to do the cube root of 7x, but I'm going to have to square it, because I would have to multiply it by itself 3 times to get rid of it. So if I do that, that's multiplying it by itself 3 times, so it gets rid of it. It's just the radicand, 7x. And then this times 1 just gives me cube root of 7x squared. And then that squared piece, remember we've talked about that, that can also be on the inside. So you're going to square this inside piece. So I'm going to take the cube root. It means the same thing as 7x times 7x, which is 49x squared over your 7x. So I'll accept either of these numerators here. All right, so part C. Notice that on this one that we have 2 terms in the denominator, which means we're going to have to use the conjugate to get rid of the radical. Notice A and B, we only had 1 term in the denominator. So I'm going to have to multiply it by its conjugate. So look at the denominator. Instead of it being 1 minus square root of 3x, it's going to have to be 1 plus square root of 3x. Now whatever I do to the denominator, I have to do the same exact thing to the numerator. So I'm having to use FOIL here. So that's 1. That's positive square root of 3x. That's minus square root of 3x. And then look at this closely. I have a negative square root of 3x times a positive square root of 3x is a negative 3x. It gets rid of the radical when I have a square root times itself, and then it's negative because of that sign there. So notice your middle terms cancel out, which is what we wanted. So we're left with 1 minus 3x in the denominator. And then the numerator, I'm going to have to distribute that. That's square root of 2. And then I can multiply these inside pieces since the indexes are the same. So plus, that would be square root of 6x. So remember we talked about in the front, in order to add radicals, they have to have the same index, but also the same index, or a radicand. So they don't. So this is our final answer. Okay, last one. So notice I have 2 terms in the denominator, so to get rid of the radical, I have to multiply by its conjugate. So write your 4, but change that sign to minus. And then I have to do the same exact thing to the numerator, so don't change the sign of the denominator, just move it up. So I'm going to have to use FOIL here because it's a binomial times a binomial. That's 16. That's negative 20 square root of x plus 20 square root of x. Look at this closely. Multiply the outsides, insides. So 5 times a negative 5 is a negative 25. And then the square root of x times the square root of x. Remember, it gets rid of the square root. It's just x there. Notice your middle terms cancel. So we're left with 16 minus 25x in the denominator. And then I have to distribute on the numerator. So that's negative 20 plus 25 square root of x. I'm not able to add any of that stuff, so that would be my final answer. So this is called rationalizing, when you need to get rid of the radical in the denominator. You can't divide by a radical. If you have any questions, please let me know.